Hi, welcome to my video on solve a system of equations number 1. Solve each. Notice I have an equation here with x minus 1 squared plus y minus 3 squared equals 0. It looks like, if you think about this equation of a circle whose center is 2, 3, but what happens? The radius is 0. So if you had a circle which has a center of 2, 3, and the radius was 0, that means you would have a point. So the point is 2, 3. So really, the solution to this equation is the point 2, 3, because when x is 2, you get 0 squared is 0. So that means what number squared will give you 0? And it would be a 3. So this equation is representing a circle which has no radius. So it's just a point, representing a point. Number 2, what about this one? So notice I look and I see a plus, I see an x squared, I see a 2y squared, and I see a trinomial. Let's see it has x's and y's. So this trinomial, let's see if we can factor it, is equal to 0. So x squared is x and x. 2y squared is 2y and a y. The product is positive 2. Sum is 3, so it has to be 2 and 1. So it has to be product is positive, sum is positive, so it has to be positive 2y, positive y. So if we did the FOIL on this, you will come up with this trinomial. That means we have x plus 2y is equal to 0, or we have x plus y is equal to 0. So if we solve this for y, we get 2y is equal to negative x, divide by 2, and I get a negative a half x. And here, if we solve this one for y, we get y equals negative x. What does that mean? Well, it means that the solution is not going to be like 2 point or 3 point or 4 point or 1 point. The solution is this line. So the solution is y equals x as a line. So this is a line y equals x. And this is the line of negative 1/2 x. So both solutions to this equation are lines. And let's check. So if you take y equals negative 1/2 x and you take points on that line, so let's take x to be 0. If x is 0, y is 0. So if we take x to be 2, so if x is 2, y is negative 1/2 times 2 is negative 1. So if we take x to be negative 2, negative 1/2 of negative 2 is 1. So you can see that there's many points that's on this line that's true. So the solution is the line that satisfies this equation. And the other line is y equals negative x. Again, if x is 0, y is 0 is one solution. If x is 1, y is negative 1. If x is negative 2, y is 2, because y is the opposite of whatever x is. They're the negatives of each other. And there's many points. So the solution is this line and this line. So whatever points satisfy this line, that's the solution to this equation. So if you take each of these points and sub it into this equation, they'll be true. You take each of these points and sub it into this equation, it's true. So there's many more points. So there's lines. Number 3, solve the system. We got a system of equations, x squared, y squared, x squared, y squared. Notice that the first one, it got an x squared, y squared with a plus. So this is an ellipse because the coefficients are 1 and 6. And this one is this. Notice we got x squared, y squared with a plus, but the coefficients are equal, 1 and 1. So 1 is an ellipse and 1 is an equation. So if we call this equation 1, and we call this equation 2, so what I'm going to do is take equation, notice the x squareds are the same, so I'm going to multiply this equation by negative 1. So that'll give me negative x squared minus 6y squared equals negative 19. And if multiply the bottom one by 1, I'll get an x squared plus y squared equals 4. Notice the x squareds are opposite of each other, so you add up, you get a negative 5 y squared equals negative 15. Divide by negative 5, y squared equals 3. So that means y is equal to plus minus the root of 3. So we got two answers for y. So y is root 3, and we also have y equals negative root 3. So we take each of these and sub into, let's say we sub it into the circle. So we sub that into x squared plus y squared equals 4. So y is root 3, so x squared is root 3 squared equals 4. X squared, the root of 3 squared is 3. So we have x squared equals 4 minus 3. X squared equals 1. So x is equal to plus minus the square root of 1, which is 1. So that means what we have is when y is root 3, x is 1. And when y is root 3, x is negative 1. So what about if we do y equals negative root 3? So again, we sub it into the equation for the circle. I could sub it into the equation for the ellipse, but the circle is better, easier to work out. So x squared is, y is a negative root 3 being squared, and negative times negative positive, root 3 times root 3 is 3. So x squared equals 4 minus 3. X squared equals 1. X equals plus or minus the square root of 1, which is 1. And so we have x is a y is a negative root 3 when x is 1. And y is a negative root 3, x is negative 1. So these are the four ordered pairs where the ellipse and the circle intersect. And again, I like solving a system of equations, but we have the squares, so I just made these opposite of each other and they cancel out. So we're solving a system of equations, this time which are quadratics, circles, ellipses, hyperbolas. Now one more to do, solve algebraically and then graph. Again, solving algebraically gives us the answers, graphing, you got to be careful. So let's look at these pairs of equations. Notice that this one is an x squared, y squared, and it's a minus and a plus. So this is a hyperbola, standard form. And this is x squared, y squared, and they're both pluses. So we have, it's not a circle, it's an ellipse. So if you look at the equations, this is equation 1, and we call this one equation 2. Notice equation 1 and equation 2 have the same y minus 1 all squared over 16. So if we added these together, we add up these two, so the common denominator is 4. So x squared add on x squared is 2x squared. They cancel out to give you 0, and 1 plus 1 is 2. So if we put it over 1 and cross multiply, we will get 2x squared equals 8. So 2x squared times 1 is 2x squared, 4 times 2 is 8. Divide by 2, x squared equals 4. That means x is equal to plus or minus the square root of 4, which is 2. So we have x equals 2, and we also have x equals negative 2. So let's sub x equals 2 into one of these two equations. So let's sub it into this one here, number 2, because that's an ellipse. I'd rather deal with the plus than the minus. So I'm going to sub in x squared over 4 plus y minus 1 squared over 16 equals 1. So x is 2. So put a 2 here. 2 squared is 4. So I get 4 over 4. Y minus 1 squared over 16 equals 1. And 4 over 4 is 1. So that's y minus 1 squared over 16 equals 1 minus 1. So that means we have y minus 1 squared over 16 equals 0. And that means, let's go over here, that means that y minus 1 squared is equal to 0. So if you put it over 1 and cross multiply, you get 16 times 0 is 0. And y minus 1 squared times 1 is y minus squared. And the square root, y minus 1, is plus or minus the root of 0, which is just 0. So y is 1. So when x is 2, y is 1. And let's put in a negative 2 into this equation. So we put in a negative 2 into this equation. We get negative 2 squared is 4. So we get 4 over 4 plus y minus 1 squared over 16 equals 1. So this equation works down to, that's a 1. And so we get y minus, that's y minus 1 squared over 16. That's a 1. 1 minus 1 gives me 0, so I get the same answer as here. So y minus 1 squared equals 0. Y minus 1, so y is 1. So that means when x is a negative 2, y is 1. So these are the 2 points where the hyperbola and the parabola intersect. So let's take the hyperbola x and we do the graph of it. Let's look at the graph of this hyperbola. And to graph the hyperbola, notice that both of these, this one is, the center for this one is 0, 1. And the center for this one is 0, 1. They both got the same centers. So the center for this hyperbola, x is 0, y is 1. So if we plot this center of 0, 1, which is right here, so this hyperbola has x-intercepts. So the x-intercepts are plus, this hyperbola, when I say x-intercept, I got to be careful. This hyperbola, because the x is negative, has the horizontal axis as its axis of intercept. So that means if we take the center, that means that a squared is 4. A is plus or minus 2. So that means if you move 2 over here from the center, you move 2 right and 2 left, that's picking up your vertices. Vertex 1 and vertex 2. And it got an conjugate vertices. So b squared is 16. So b is plus or minus 4. So from the center, we go up 4, 1, 2, 3, 4, right here. And we go down 4, 1, 2, 3, 4. So because it's a hyperbola, that means that we can have an asymptote that's going to be y minus k plus or minus b over a x minus h. So that's, the center is 1, so that's a y minus 1 plus or minus b is 4, a is 2, and the x is 0, so that's an x minus 0. So the asymptote is y minus 1 equals plus or minus 2x. So one asymptote is y minus 1 equals 2x, and the other one is y minus 1 equals negative 2x. And we could bring the negative 1 over negative 1. But let's graph it. It passes through this center, and it rises 2 and run 1. Rise 2, run 1. Rise 2 and run 1. So we got here. Or we can go down 2, left 1. Down 2, left 1. So this is the one asymptote, which is y minus 1 equals 2x. And the other one is negative. So we go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, 1 is there. Or from the center, we can go up 2, left 1, up 2, left 1. And so there's the other asymptote. And so what we have is that it cuts the horizontal. So it does this. It goes through the vertex towards the asymptotes, but it don't cut through. Now we didn't need to do the foci. We just needed to draw with the vertices and the asymptote. Now I could have put the rectangle in here like this, but again I didn't. Here's the rectangle. Now let's draw the ellipse. So I got an x squared over 4 plus y minus 1 squared over 16 equals 1. Again, the center of this ellipse is 0, 1. So there's the center. And a squared is 4. A is plus or minus 2, so it's the same for both. B squared is 16, so B is plus or minus 4. And because it's an ellipse, then it has the A is 2 to the left, which is right here, and 2 to the right, which is right here, and the Y is 4 up. So this is the vertices, and this is the co-vertices. When you leave here and go 4 up, you hit here. When you leave the center and go 4 down, you hit here. So ellipse is oval, so it passes through these 2 points and these 2 points. So this is the ellipse doing this. So these are the 2 vertices here. These are the 2 co-vertices right here. And so the intersection between these two is, this point here is, that's 2, 1. And this point here is negative 2, 1. So I solved them algebraically, which wasn't too bad, and I graphed them. But again, graphing them is not a good way to solve a system of equations, because you might not be, the points might not be nice points. They could be fractions or irrationals, etc. So that's solving a system of equations, number 1. And again, if you like my video, click the like button, click the subscribe button. If you'd like to look at my channel, and if you want to visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.